Welcome everybody. It's always nice to see the old pipe hat crowd in here. Okay, for a bit of translation of HL7 version 2 to FHIR. And I have a confession to make. We have been thinking about this transformation and having brainstorm sessions about this, I think, since around 2015. And I've done a few presentations on the subject, but it was always based on hearsay. So I was talking to other programmers and they were telling me what their best practices were. And then I would update my PowerPoint presentation and I would present it again. And earlier this year, this being an implementers conference, I thought, well, you know what? Although I'm not a real hardcore programmer, I'm going to write just some Python code to actually do this. Generically create something hard-coded in Python to go from version 2 to FHIR. Not worry, I'm not going to talk about Python at all. But it showed me some of the problems that you're then obviously faced when you're trying to do that. So again, I included those in this talk. So version 2 to FHIR. And more specifically, and I also put that very specifically in the description of this talk, a transformation from version 2 messages, which you may know is event-based, and then we emit some sort of message, and then storing the data that's contained in the message in a FHIR store, in FHIR resources. So this talk is not about transforming version 2 messages into FHIR messages, because that's easier. We don't want to look at easy stuff, right? We are going to go for the hard thing. To make it a bit more interesting, my use case here, my example is going to assume that we have an ADT system and a lab system, and they both send a version 2 feed to some sort of transformation software, which updates whatever we have in our store. Now, obviously, if you look at the version 2 message and you go like, oh, transformation is easy, right? Message header resource, patient resource, an encounter resource, and a couple of allergy intolerances. Hey, presto, a bit of field mapping, done. Cool. If you still think that at the end of this presentation, then I have failed to communicate the key points, right? So at this level, it looks relatively easy, but it isn't. And actually HL7 itself, and it's a great starting point for whatever you're doing in this transformation space, HL7 itself has already created mappings. These are essentially spreadsheets that show you the relationship at a rather detailed level, at the segment level, at the message level, and even at the data type level, between the version 2 side and the FHIR side. Link is here, and if you Google on version 2 to FHIR mapping, you will find the implementation guide as well. But this is just mapping the information model, essentially as if we are translating version 2 messages to FHIR messages. Okay, that's cool, but that's not our use case here. Okay, and the use case that I'm using version 2 data to essentially populate a clinical data repository, that's something that quite a lot of healthcare providers are actually doing. Now, the key difference lies, and this is where all the problems lie, or a lot of the problems are derived from the fact that we're dealing on the one hand with a messaging paradigm, and on the other side with REST. And messaging is always about an ongoing workflow. It's the situation as it is now. Where's the patient now? What's the status of an activity now? We don't care about yesterday. I mean, that's yesterday's news. Who cares about that, right? In the CDR setting, when you are creating a clinical data repository, you very much care about things that are in the past, or now, or in the future, things that we have planned. Right? So that's already an example where you feel like, okay, that's a fundamental different way of thinking. And that's where quite a lot of the problems lie, as we will see. Now, to give you a bit of an architectural picture, no surprises here really. So if we have a version 2 enabled application, then we have a business process API, we have event detection, and whenever some sort of version 2 event happens, we encode a message, send it in our use case here to some message decoding, map it to resources, send it to some receiving application. Nothing new there, right? And we leave it to this application effectively, which has a FHIR API to then update whatever persistence layer it has. Now, it could very well be that this persistence layer is this FHIR repository. so that we're using FHIR as a persistence layer, which is not always necessarily a good idea, but there are certainly lots of scenarios where it is a good idea. So yes, you could do this mapping to the resources and then go straight to the persistence layer. There's a bit of a problem with that, as we will see, because here, at least if you go via an application, you have merge logic between the pre-existing information and the new information. And that's basically not part of a standard FHIR API. So again, that's one of the problems that we encounter. So in 2015, when we started thinking about this, we said, oh, maybe we can transform this message, which is a collection of segments, into a bundle of FHIR resources, a transaction. Because in a transaction, you have transactional integrity, so we can basically either have all of this updated or nothing. It's actually kind of a close equivalent. If we don't have messages on the receiving side, let's go for a transaction as a kind of fallback mechanism. Next best thing. Okay, now given that this is an ADT A04, in other words, the start of an outpatient encounter, I am already aware that this is going to be a new patient. So I need to, well, either create a new patient or update that patient. It's a new encounter, so by definition, A04, I know this needs to be a post of a new encounter for that particular patient. In the transaction, where I have 3 allergies in my message, I will have to, and this is where the difficulty starts, I will either have to update this list, because there may already be allergies for this patient on the receiving side, or I may need to update them or create new ones. I actually don't really know. But in transactions, like in REST, you can do conditional operations to deal with that. For example, you can do an update, which is really an upsert in FHIR, and go like, well, I want to update the patient with this business identifier, let's say the national citizen identifier or something. But if it already exists, then it will be updated, and if it doesn't exist, then we're going to create it. Ah, that's nice. So if the allergy doesn't exist yet, then it's going to be created, and if it already exists, it will be updated, which is exactly what I want. So transactions in combination with conditional operations actually sounds like a pretty solid and easy way, basically, to map your messages to FHIR. Now, just to get you thinking, kind of a little exercise, right? I'm not going to ask you to answer, but just let this go through your mind. How would you solve this? Let's map PID, the patient identifier. You see an example here. Okay, so how would you do that? Well, obviously it maps to patient.identifier. That's not really that much of a problem. But the problem lies in the fact that the CX data type, okay, is implemented in a lot of different ways, which means sometimes you may have information about the namespace, the system that assigned the identifier, and sometimes you don't. And what should you do in the case that you don't have a system identifier? So you only know patient ID is 123. Right? So this is going to have issues. If my patient 123 is another patient, then the patient known as 123 in another system, then... So I decided in my little Python approach that, oh, I'm always going to create some system URL, even if I can only base it on MSH3. MSH3 is the sending application. So if this a patient that is communicated by the lab system, I can create a dummy URL that ends with /lab. Okay? So I will always have a unique identifier, thus avoiding that I'm associating the wrong clinical data with the wrong patient. Now, HL7 version 2, as you well know, is a lot less strict about how you deal with this sort of information than FHIR is. Most implementation guides will tell you that you should, at least, or shall have, for example, the system associated with an identifier. But based on the fields that may or may not be there, and you can always fall back on MSH3, which needs to be there, you can construct your own semi-dummy URL for the identification system. Another one. PV119, the visit number. Okay, how does that map? And what do you do if it's empty in version 2? Because that's going to wreak havoc down the road, because we may at a prospective date need to update the encounter, and the encounter doesn't have a unique identifier in version 2. How are we going to do that, right? So yes, it's again the CX data type. We map it to encounter.identifier. And again, if you don't have a system, you can again use MSH3 or some other workaround to create a new unique URL. If PV119 is empty, you may wish to use something like, it's an encounter with this specific attending physician on a specific date. And the date and the identifier of the attending physician and the encounter type, that's kind of a tuple that is unique in most healthcare environments. But again, I'm making some assumptions, but the assumptions are probably fair. Right, so what I'm doing is creating a generic translator, right? So this is not a translator that has been tweaked for a particular dialect of version 2. I'm trying to create a generic solution and pointing out some of the issues. So yes, this may lead PV119 to a conditional update, but the conditional update could be based on the encounter identifier or on this tuple that I talked about before, if PV119 is empty. So identity management turns out to be one of the main problems here. How am I sure that I'm updating the right FHIR resource or deleting the right FHIR resource? And that turns out to be a real problem, because in FHIR, as you know, all resources have a logical identifier. And then you start looking at version 2 and you go like, oh, do we have an equivalent for a logical identifier? Do we actually have one somewhere? Well, yes. The control ID in the message, you know, that's a unique message identifier. That's effectively a logical identifier. But that's just the message as a whole. That doesn't go for an allergy and not for an observation. You don't have anything of that. So what you have in version 2, you mainly have these business identifiers. I have an order number, I have a patient number, I have a clinician identifier. These are business identifiers. But then again, there's nothing that guarantees that the same practitioner is not on the store twice. Because the logical identifier is unique, but the business identifier is not. So you may have multiple patients with the same citizen number. So duplicate detection and duplicate avoidance is certainly one of the key things that really have to be looked after. Now for this one. PV117, the admitting physician. It's actually a field that's quite often populated when we're talking about visits or encounters using FHIR terminology. So here we have a Frank Jensen. Okay, so this is the value of the field. And you go like, okay, so what should this look like in FHIR? Well, actually what this means is that the encounter has a reference to a practitioner resource, and the new, potentially, practitioner resource has to have that identifier and the name and telephone number, whatever is in here. Aha. So my PV1, this particular field, is actually maps to a set of multiple resources that may or may not already exist. Based, obviously, trying to detect whether I already have that provider based on the unique identifier, which doesn't have a system URL, so I will have to make one up again based on perhaps MSH3. Yeah, so XCN data type, you may have to create it, update it. Identifier is in the first subcomponent, as you can see, but avoidance of duplicates, as I said, it's really a real problem here. So, even though I tried in my code, and you're probably going to try that as well, to avoid creation of duplicates as much as possible, as I can, I still think it's recommended that you create a process, a periodic process, maybe something you run once a night, to try and detect, well, somehow, do we still have duplicates? Do we have multiple patients with the same citizen number? It's not supposed to happen, I fully realize that. But if it happens, and it will happen, we all know that, okay, let's at least detect them. And maybe automatically or not automatically merge them again. Okay, let's go back. Remember, we're still essentially working on translating version 2 messages to FHIR transactions. That's still the sort of the thinking that we're currently having. So let's now say we have this in a message. How are you going to translate that? Well, certainly it's 3 allergies, allergy intolerances. The problem is that in a message you will only have the active allergies, the ones that are valid now, because that's what messaging is all about. But in a CDR, you also want to know about the inactive allergies, the allergies that are no longer relevant. Why would you want to know about that? Well, for example, they could flare up again, right? So you want to have that in your list. Now it gets interesting. Messaging is snapshot based, right? It only sends you what currently is relevant. But that means that if you first send these 3 allergies, and 10 minutes later you receive a message that only contains 2 allergies, then that just means that we're effectively, one of them has to go to inactive. But that information is not in the message itself. So here we run into problems, and that's why transactions are not going to work anymore. Workaround around identity management that I've chosen, but that's an implementation choice. There is no unique identifier in these allergies, but I can grab the code and effectively turn that into an identifier for this particular allergy. So at least I will have a unique identifier. Whether that's entirely safe, that's a different thing, but you need workarounds. Now, to solve this allergy issue, you have to use provenance. And provenance, as you probably know, or hopefully know, allows you to specify who has done what to a particular set of resources. In this case, where did the data come from? I have this bucket load of FHIR resources, and they were generated, they were translated from a version 2 message from a certain sender. And why do you need that? Well, go back to our allergies. So if I translate my list of 3 allergies, I'm going to associate with these 3 allergies the provenance that says this was recorded, originated effectively at this point in time from that device, and the device represents the string value that we have in message header 3, which is the sending software application, right? So now we know that, so from that software application we received these 3 allergies. Okay, now you receive the next message and it only contains 2 allergies from the same sending application. And then you know, oh, wait a second, okay, it's that sending application. What do I already know from them? From them I already have 3, and now they're sending me 2, which implicitly means that the other one has gone inactive. So I need this provenance effectively to detect that now one of the allergies has gone inactive. But this means that if you are the transformation agent in the middle, the transformation software, it means that you have to have knowledge of what's on the destination before you can actually execute the mapping properly. And that means that transactions are not going to work. Because in a transaction you have no knowledge of what's going to happen on the server. You try to basically create the equivalent of the message, throw it over the wall, and basically let it to be the CDR's problem. But it doesn't work. So transactions, probably not. Depends a bit on your use case. If you have simple use cases, then transactions may actually work for you. Okay, but if you are looking for a full-fledged solutions, then transactions are not going to cut it. Okay, so nice idea, but not necessarily try this at home, right? So what we cannot do is, if you have anything that requires you knowing the old state of things before you actually do stuff, you have to use something different. Perhaps a full-fledged RESTful approach somehow. And this is also where patch comes into place. It's not used that commonly in the FHIR space of the REST verbs. Put, post, delete, etc. You probably know. Patch allows you to update parts of a FHIR resource. And transactions dealing with out-of-order messages. That's obviously not a problem, which we are well familiar with in version 2, that if you have multiple parties sending you stuff, then it's not necessarily that all those messages will arrive in order, which means your repository is going to contain the wrong data. So you need to be able to deal with that as well. Because this scenario kind of assumes that this transformation software, whatever it is in full control over the contents of the Firestore. Well, that's nice in theory, but in practice what we're going to see is obviously there are going to be EHR systems that also update and read whatever we have in here. Potentially. So you're not a full master of the data here. And that more or less means that you always will have to more or less inspect what's already there before you can actually start updating it. But you better be smart about that, on how you do that. Now, as I said, you can use this patch mechanism to do a partial update on an existing FHIR resource without actually fetching it first if you want to. You can fetch it first, update it, and then post it, put it again if you really want to do that. Or you can use patch. And patch has the advantage that you can also support our famous double quotes and the empty separators. Because this is unknown, but it means that it's unknown to me as the sender of the message, but if you already have data, don't delete it, please, because I don't know. It could be very well that you know. And here it says, if you have data, remove it for that particular field or component. Right? So these are things that you could do with patch. So there are a few approaches that deal with translations to version 2 by only using patch. Patch on all resources. I'm not sure whether that's really the best way to do things. And patch assumes that the resource already exists on the server. So that's another problem here. So if we revisit this architectural picture, then this is what we have seen before. But a key thing here is the merge logic. Somebody has to decide on these complex rules. Identity management, when is something the same thing as what we already have? Should I pull it, then update it, or replace it fully? Or that's the merge logic. And as I said, normally your business level API will take care of that if you're talking about an EHR or hospital information system. Like as if somebody in the user interface starts typing and updating something, well, there's also merge logic with what you have in your database. But if you go directly to a persistence layer, a Firestore, right, there is no merge logic. So you will either have to, in your mapping software, or as a kind of part of your facade, if you're using that type of system, you will have to have some merge logic in there as well. And that's the complex bit. It's not how do you transform this data item in version 2 and map it to a FHIR data item. Yeah, okay, those are the mappings that HL7 has created, and they're great. Good starting point. Okay, but you need more to actually solve this. Now, we've also seen approaches that people go like, okay, well, if I have to know really what goes on there before I'm allowed to do updates, I could have my own repository here, kind of as a cache. So I don't have to always expect that. I can inspect my local cache, which is for performance reasons, and then basically deal with my mapping. This could also be, interestingly enough, a version 2 type of database. I have a PID table, which just contains the raw PID string, and I have a PV1 table. Okay, so I'm going to maintain some level of history of messages that have flowed, or I have translated them to FHIR and I have my lone copy of what I have sent before to them. And then if you are thinking about Kafka and these other architectures about event handling, right, we have version 2 events. So you could basically store those events, and then you can do even fancy things like event replay. Okay, I've installed the backup and I please send all the last messages from 24 hours again. You just replay the event list. Okay, so that's one of the options that you then have if you add that into the mix. But again, it depends a bit on your architecture, on how you're dealing with that. Okay, so you can create pretty fancy solutions in this space. Now, You may wish to do filtering, and this is what almost everybody does. If you have a communication server of sorts, you will have this as well. You're going to accept patient identifier updates, PID updates, from certain systems, but not from other systems. Simply because you do not find them reliable. I don't want my lab systems basically to update a patient demographics. Unless I don't know the patient, in that case I'm going to take whatever the lab system has. Right? So this is not a new thing, but it's again another component that needs to be done by this transformation software. Duplicate content, you can avoid a lot of transformations by just inspecting the message. I get this message from the hospital information system, and I do a string comparison at the segment level. The PID you're sending me now is the same string as the PID you sent me an hour ago. But that means I don't have to transform the PID again, because nothing has changed. Now, because version 2 messages by their very nature of the messaging exchange mechanism are very rich, there are tons of segments in there, actually most of them will be the same as the last time around. So you can avoid quite a lot of processing by doing that. Not all out-of-the-box communication servers can actually do this, but it seems like a very good idea to do it. Then the other thing is this concurrency and out-of-order messages. And that's certainly something that you have to be aware of. So if this is the time that you actually received those messages, whereas this is the event time within the message. So we have a flipped communication here, which can happen. And what you see that some of these message transformers are doing is they're just caching the incoming messages and go like, I'm going to wait for 30 seconds or a minute. So I can reorder the messages that were received out of order within that time frame of a minute. And a time frame of a minute is probably okay. I once had it explained to me where somebody says, well, as long as the message arrives at the destination before the patient does, I'm okay with the delay. Okay? Because moving a patient takes a lot longer than actually sending the message or keeping it on hold for 30 seconds. Data cleansing. If you are in the middle and you receive from a version 2 message minimalistic information about a practitioner, you might as well do data enrichment and data cleansing. I'm going to go out to the National Healthcare Provider Registry and pull all the additional demographics. Go to the Citizen Registry and get hold of all the citizen demographics details. So I can enrich my data with that. Okay, in general, all sorts of data cleansing techniques, and there's a whole suite of them, you can basically have them as part of this transformation. Data duplication techniques. I cannot mention that often enough, because it's going to happen. In the version 2 to FHIR space, it's very difficult to avoid the creation of duplicates. Now, to show you that this is not just theoretical, okay, this was from actually a Google slide. And Google actually talked about yesterday about version 2 to FHIR transformation in their keynote as well. So this is for a typical US provider, but I found out later that this also applies to some larger Dutch hospitals that have the same numbers. Where you're like, okay, so if we have 5 million V2 messages per day, then that equates to 100 million resources, right? Which happens to be 73 terabyte of FHIR resources. So those are the numbers we're talking about, which means you really have to worry about performance here, because this is not going to be evenly spread over the day. This is going to happen with large peaks at certain points in time. Okay, for example, when all your patients are admitted or discharged, there are certain set times of the day where you have huge peaks basically in the number of messages. You better be able to deal with that if you're in a large provider setting. So in that sense, it's not that easy. So it makes sense for Google to also look at that particular problem. So to summarize on our version 2 to FHIR, mainly focusing on version 2 to FHIR, okay, there's lots of work being done in this area because everybody needs this. You're going to populate your data repository with a feed you already have, which is V2, right? So there are two ways of dealing with that. Yes, version 2 messages to FHIR messages. Cool, that mapping is relatively straightforward. And if you're in a RESTful environment, you can post your FHIR message to an operation which is process message, but the FHIR specification doesn't tell you how to implement that. That's left up to the server to do, which basically means all the complexity around merging the data in the message with the existing stuff, it's hidden in the operation, but you will still have to do it. But still is still relatively rare. It does occur, but relatively rare. And the provided mappings that we have from HL7 are actually pretty good if you are working on this. If you map it to a FHIR server, which was the subject of my talk, okay, then maybe you can get away with transactions if you have some simple stuff. But for almost everything, you will have to do more complex approaches based on REST. You can always go the other way around. I have this FHIR-based EHR, and I want to spit out version 2 messages. And then the main challenge there is the event detection. How do I detect if I have this generic FHIR server out there, A04? How do you detect that? How do you detect a patient merge? So this is, again, in FHIR terms, this is quite closely related to subscription, because if you subscribe to an event, right, you have to be able to detect the event. So the event detection that we have in the subscription mechanism in FHIR is similar to the event detection mechanism that we actually need for this mapping. But that's not the topic of my presentation today, but just to show you the main challenge if you want to go the other way around. All right? I hope this was food for thought and gave you some ideas as to some of the problems and best practices around the mapping of version 2 to FHIR.
So yeah, thanks Rene. We still got time for questions. I don't see any from the online audience yet. There we have a question coming up.
Rene, thank you for your talk. Quite interesting to see that you start as an intermediate, let's say, library or functionality, just first translating message to FHIR request. And then you continue and continue. And what I hear from your talk is you run into a lot of issues with messages, merging messages, in out of order messages. How are those problems resolved in standard EHR HL7 implementations? Yeah, you had your merge logic and the business logic. They're doing basically exactly the same things as what you're doing. They're looking up some kind of a query into the database to check whether the data is already there. Are you now not re-implementing a HL7 EHR system, CDR system, in which you're basically just replacing the low-level database access layer?
Well, some people choose to do that. But that's, for this particular presentation, I was assuming that as a given, because that's what people are doing, regardless of what I personally think about whether that's a good idea or not. It's gonna happen, you have a data feed. As to the issue around concurrency and out-of-order messages, yes, those are problems you already have in general version 2 messaging space. They already occur. But it's more like data cleansing is also something that occurs in messaging. So I'm more or less pointing out that, especially because version 2 in some areas is less rich than FHIR, that makes the requirement for data enrichment and cleansing even more urgent than in a normal version 2 message going from A to B. Okay?
Anyone else? Nice.
Hi, thank you for the talk. It's a detail, but you said that batch is not possible within a transaction. Any reason for that?
I didn't use the word batch, I hope.
Sorry, I misunderstood that.
It's basically, the simple approach is to transform a version 2 message into a FHIR transaction bundle. But that won't work, and I use the elegy use case to point out why that won't work. Because that's a use case where the transforming party that sits in the middle has to have prior knowledge of what's already in the CDR before they can make a decision how to translate it. And in a transaction, you cannot do that.
But it is possible to just go fetch the data you need and then build your transaction.
You could certainly do that.
Any reasons why it's a good idea or a bad idea?
Oh, it may actually be a good idea. I don't know, I haven't thought of that. But it's the underlying, what people were trying to do is to go straight from a message to a transaction.
That's never going to work.
Okay, so we agree on that one. As for, okay, I'm going to first inspect and then build, not use individual REST calls, but use a bundle, a transaction bundle. Cool with me, I don't see a problem with that.
Okay, thank you.
May actually have advantages. It's the next version of the presentation. There you go.
Okay, if there are no further questions, I would say let's give applause to Rene for the wonderful presentation.